Here we go with part 2 of week 2, and we're talking about the structure of the atom, basically looking at the number of subatomic particles in the atom. Two main things we're going to need to know: atomic number and the mass number of the atom. The atomic number is the number of protons that are found in the atom. It's what makes up what the atom is. The example I gave there, you have carbon showing 6. So it's got an atomic number of 6. It has 6 protons. It will not be carbon if it has 7, 8, 9, or less than 6. In order for it to be carbon, it has to have 6 protons. Now, we won't talk the other ones. Protons and neutrons can eventually change. The protons will never change. The atomic number is also, as long as it's a neutral atom and not an ion, the number of electrons will equal that atomic number also. So the atomic number is technically the number of protons and the number of electrons because it's neutral, so the number of positive charges have to equal the number of negative charges. The other thing we need to know is the mass number. Mass number is the number of protons and neutrons. Because as we learned on the last part, that the 99.9% of the mass is contained in the nucleus, which is the protons and neutrons. And basically, for our calculations, it's going to be 100%. So those subatomic particles start with a real easy example. The atomic number is the number of protons. So hydrogen has an atomic number 1, must have 1 proton. Carbon's atomic number is 6, so it must have 6 protons. You can go the opposite way and say that the number of protons also going to equal what the element is. It is the easiest part of finding the subatomic particles. The mass number, which is the protons and the neutrons, now that's a little bit different. If hydrogen had a mass of 3, it's not going to change. It still only has 1 proton, but it must have 2 neutrons because the protons plus the neutrons has to equal the atomic number. Another way to think about it is if we want to find the number of neutrons, it's the mass number minus the atomic number. So if we're looking at a part of the periodic table here, if we're looking at something here, I picked this one. I know it's got something written right there, but it was the one that actually showed oxygen as being 16 instead of 15.99. When you see 15.99, that is an average of all naturally occurring oxygens. But this number, in order to find the number of particles of protons and neutrons, has to be a whole number. So I found this one that had 16. But you have the atomic number up here. You have the symbol. You have the atomic, the name of the element, and then you'll have the mass number, sometimes called atomic mass. An easy way to think about it, like I said, this last slide, just saying electrons equal the number of protons. An easy way to remember it is by looking at the word ape man, where ape stands for the atomic number is equal to the protons is equal to the electrons, A, P, and E. And then the man portion is going to be mass number minus atomic number equals neutrons, M, A, and N. Ape man. Easy way to try and remember how to find the particles. So give you an example real quick, and then you'll have some example in the homeworks. Chlorine has a mass of 35, an atomic number of 17. So as soon as we know the atomic number is 17, that's the number of protons and the number of electrons. To find the number of neutrons, you have to take the mass number and subtract. So 35 minus 17 is 18. If we were to do potassium in this case, its mass number of 39, but has an atomic number of 19. Protons would then be the atomic number, so that's 19, which has then got to be the same as the electrons down there. And to find the neutrons, 39 minus 19 equals 20. So you'd have 19, 20, and then 19 over in the electrons. That was the end. You have some practice and some handouts that might help you out. Don't forget to look at the PowerPoints, look at the handouts on your Google Slides, and then email if you have any questions at mark.boer@addisonschools.us. Thanks, and see you next week.